This is my week 3 coding assignment. So I guess I'll just step through it line by line as quick as I can. I'm importing some array tools. I'm importing a library for storing geometry, which I will talk about later. So if I just go ahead and run it, it runs without errors, and you can see that the first thing I'm doing is running a function that takes the last integer in this array and subtracts the first integer and returns 90. It does it again with another array. I did all these first ones in functions because they were asking me to reuse them and it was annoying. So I just modularized it. Then I am taking the average of the array, and that's 28. It's an integer. I learned that you can overload functions, meaning that they will give you different results with different parameters. So you rewrite the function using the same name but different parameters and give it kind of slightly different behavior. So average array, if you pass it integers, will average integers, and if you pass it a array of strings, it will average the length. Concat array concatenates the whole string. And let's see here. Concat array lengths is again using the I'm building an array based on array lengths, and then I am summing that. So it's going to add up all of the values in that array. I print out the word times integer, build a full name, and then an array to test if the values in an array and are add up to 100. And then I've got average array here, clock for doubles, so it's giving you a value, average value of doubles. I build a second array and then compare the two. The second array is bigger than the first, so it gets false. And then we just run will buy a drink, true 1051, so that gives you a true. And then here's my function that I wrote. So what this does is it takes 2 points, and we'll go ahead and look at the function itself. And basically it's just using the Pythagorean theorem to find a squared and b squared, then it takes the square root of that. So I've got a really simple use case. You would never do this with integers in any kind of GIS. It would always be a double. And I talk here a bit about how it's really scary to have like floating point arithmetic errors in coordinate space, because coordinates go really far from the origin, so you could have really high numbers and you would still want that precision. So there are some other libraries that have already implemented this and presumably taken that into account. So I'm looking forward to learning more about those. So that's kind of the project in a nutshell. Again, if I just run it, it runs no errors. So